Hey, everybody.
Great. Well, it looks like we have a good number of folks in, and so just in the interest of time for the content we have to get through, I'm going to go ahead and start today's office hours. Thanks everyone for joining. I've put the links that I'll share out here on screen in chat as well, but just want to remind everyone of our office hours format. We have this weekly office hours for those in US and EMEA to be able to join and ask any questions and learn about new features we've released from Semantic Kernel. That's weekly from 8 to 9 a.m. Pacific time. And then we have our monthly APAC office hours as well. That's the second Wednesday each month from 4 to 5 p.m. Pacific time if you do have individuals in your companies who are in other locations and want to join in as well. So just want to remind everyone of the format. We do have a new release. We have .NET at 1.20.0. And so there are some changes in terms of different samples that have been added in for OpenAI. There's structured outputs, which we'll cover in a bit more depth here shortly as well. But if you haven't had a chance to check out this new release, we recommend you do. And I've also linked to it in chat. In terms of documentation update, you'll be seeing some additional updates from our team. We have gone through and restructured for concepts and are starting some of our updates there. There's been some updated sections that we've chatted about for function calling, for telemetry, and for other items as well. But on the left-hand side, you can see our updated table of formatting changes. And so you will be seeing in the coming days updates to our pages around planners and prompts and others as well, but wanted to let everyone know that we've been hearing your feedback and really appreciate that and are making changes in a multi-stage approach. And so you'll see this first wave of updates as well. And then in terms of roadmap, I've linked to it within chat. I know individuals are always looking to see what's coming next. And so if you're wanting to be able to see what items in particular we're working on, I recommend you take the link in chat and dive into it further. And it'll cover a lot of areas around agents, AI services, and memory, which I know are some of the top ones that individuals like to learn more about as well. And then from that, I just have one more announcement around some blogs that we have out from our work in automatic function calling and for new availabilities. There we have an updated blog. We'll also have Sergey shortly going through some of those items. And then we do have an upcoming event in Korea. We have a blog post out in Korean as well to be able to detail a bit more on the YouTube channel, be able to join and get recordings. We'll also post that after the event. So if you're not able to join live, but this will be on October 17th. But with that, I'm going to go ahead and turn it over to Evan to go through some new updates. Evan, over to you.
Awesome. Thank you, Sophia. I'm really excited. I'm going to put a few links in the chats. And for today, I want to share a little bit about a new framework that we just launched this morning. So you'll see it in the new .NET build that went out just a few minutes ago. And there's a few links to the blog, Learn Sites, and the .NET sample. So I'll tell you a little bit about what this is and why we built it, but it's called the Process Framework. And really, as just a level set with everyone, right, Semantic Kernel is built for that enterprise app dev. That is really why we're here, and we're here to solve enterprise needs. And the team's been doing a lot of work to figure out, okay, how do we really help you, for your business processes, for the enterprises that you serve? How do we have AI be injected into that business process? So if you're not sure what a business process is, maybe we'll start with that. So a business process, it begins with a mission objective. So this external event happens, maybe it's a customer reaching out, maybe it's some event from a database that happens or some trigger. And it ends with an achievement of the business objective that provides real value to the customer. So that's really what we started to think about is, if we want to help you be successful, if we want to help really get this leverage with AI, how do we do that? So we started to break down what a business process is. It's a collection of those structured activities or tasks. It's the sequence of those tasks that you need to do to add value to a product or service. It serves a real business goal and it's for customers. So we said, okay, with those pieces in mind, Can we go create something, again, that's going to help ground AI, really focus on your exact business process? And that's where we want to introduce today this process framework from Semantic Kernel. So what you can do with this, and we'll go into the details in just a minute, but we want you to be able to leverage all of your SK investments. So all the code that you've already built, the systems that you're tying into, the models, the vector stores, all those type of things, your plugins, you can leverage that with AI here. We want you to also be able to collaborate with your business peers to talk about what is that process that you want to automate or streamline. How do you streamline different steps within that? And then how do you control the flow in a repeatable way? And this is really the key. As we've been thinking about this internally, one of the questions that we got a lot was, well, why would I use the process framework versus just using Semantic Kernel? And it's that last piece right here. If you have a very defined and repeatable process that needs to happen over and over and over again, maybe that's something like account opening. Maybe you have quarterly reports that need to be generated the same way each time, right? But you're pulling from different systems, they're going to be slightly different. That's when you're going to want to use something like the process framework. All right, so let's talk a little bit about, what are the terminology, and that way we kind of ground ourselves in that before we start to dive into the details. So one is a process, right? So again, that's just a collection of steps, right, to meet that business goal. The nice thing here with the with the process framework is it's fully stateful. So what that means is I can have these really long running processes and come back. This could be over days or weeks or months or even a year. And I can start to ask questions of that process, see where we are, see telemetry end to end. So I can have very auditable processes. So that's what a process is. Within a process, I have steps. So this is the activity that happens to meet part of that larger goal. These are also stateful and reusable and event-driven. So we'll talk about what that means. And then the last thing we'll ground ourselves in from a terminology that we'll talk about is a pattern. So a pattern is how do I lay out the steps to do exactly what I need to do. All right, so what does this look like? So we have a process. We have these different steps, and the steps can be ordered in different ways based on what your needs are. And then I can define what are those patterns. So the pattern I'm showing here is called a fan out. So we're going from step 3, we're going to fan out to step 4, A and B. And then when both of those are done, I can go into step 5, and step 5 can wait until that happens. So that's generally what this is all about. All right, so what is a process? We talked about that. Again, it's fully stateful. So I can hold state there for these long running processes. They're reusable. We'll see what that means in just a minute. So I can have a process call another process or kind of a sub process. This whole system is event driven. So I can have these listeners that I can route, and I can even use something called cloud events. We'll talk about that in a second. And then it's fully scalable. So rather than Semantic Kernel team creating our own runtime for this, we looked at the marketplace and we said, okay, what's available out here that will allow you at enterprise scale and global scale to use this today? So we'll talk a little bit about what that looks like. And it's a lot of technology that you've probably already heard or used in the past. So when I have process states, that means I can start to ask questions like, hey, how many steps are in this process? Where are we? Is a step sort of stuck waiting on either a human or some other event to happen? So I can start to get that type of information from the state of a process. I mentioned too the event handlers, right? So remember, when you start a process, it's some external event. That could be a human, on a website. That could also be one of these cloud events. So maybe when I get something from EventGrid or GitHub or IBM Code Engine, when something happens to start my process, I can go feed that in, grab that item, and then start from my first step and then flow all the way down based on what I'm trying to do. I mentioned the deployable pieces. So how do I deploy this? We have 2 different deployment models. So one's available, and then we're going to have another one. So one is Microsoft Orleans. If you haven't had a chance to take a look at that, we have some links in the documentation and in the blog site for it, or the blog post. This is really like .NET Core is what it's made for. You can run it on Linux, Windows, Mac OS. And because everything around these processes is stateful, you can pick how you want to store the state. So for example, in Orleans, maybe I could store the state in something like Cosmos DB or blob storage. Dapper is another option. This is for .NET, Python, and Java, so all of our kernels. So if you are not running .NET, this might be a good option for you there. This one is open source, and it also supports more pieces to store state in. So not just Microsoft pieces, but if you are running on different clouds or different type of technology, you can also use Dapper to hold state in those technologies. So those are out there. We wanted to pick something that was already, industry standards, large scale, already GA, and both of these fit that bill. All right, so let's talk about, a step. We've talked about the process at the highest level. What is a step? What does it do? Well, again, fully stateful. So I can know, where are we? Is this paused? Is this done? It's reusable. So I can create one step and use it across one process. I can use one step across many processes if I want. It's fully dynamic. So I can go and actually go call out these, a step that I have and reuse that many times or have it go one to many. It's flexible. We'll talk about what that is. There's different types of steps that you can implement. And then the nice thing here, like I mentioned, fully auditable. So because we're leveraging the open telemetry that we've been talking about in this meeting in the past, inside of Semantic Kernel already, you can leverage that across the board. And then also Dapper in Orleans has some telemetry that you can also get. So you can start to see how long a process is running, where are we, right? So you can get all the way down to the details from Semantic Kernel, and then all the way up to a high level process of what's happening. You get both of those together. All right, so let's look at these two processes, right? So I have the one on the far right, responsible AI and safety. So this is a process I may want to reuse across many different processes that I have. And what it does is it takes input in. We call something like prompt shields to go check for prompt injection and safety. And then I need to format the output because maybe I have on my website, a JSON format that I'm looking for so I can push the information back out to the user. And then on the left, I have my website Q&A. So with this process, again, this is maybe my process for my website, so anyone can go in and ask a question. So I can receive an ask that comes in from the user. I can then go call out to my responsible AI and safety subprocess here, right? So I can pass in the ask that comes in. I can go pass it over to my subprocess. My subprocess can run. When it's done, it can return, yep, everything looks good and safe. Let's go look up that answer, right? When even the answer comes back, we can go and call that same subprocess again. So you have something like that. And then you can also see that format results, right? Because I'm formatting that for my website every time, I don't want to have to, as an engineer, like go and make that and copy it over and over and over again, right? I can just use that once and then reuse that across these processes, but maybe a lot of other processes. All right, so let's talk about step flexibility. I mentioned this earlier. This is where I think the power really comes in. So if you think about your business process, there's a lot of processes where you already have code out there, whether it's again .NET, C#, Java. You just need to use that code as part of the process, right? Those are things you already do today. So great, you can continue to do that. You can also call AI APIs, so things like plugins. We support that. So maybe I want to make a remote call out to some other core system and check and go get data and pull that back in. I can do that. The nice thing here too is this works with our agent framework. So if you're not familiar with that, we have a Semantic Kernel agent framework that works with single agents and multi-agents that can be working on a task inside of my step. So what this means is I can either build all this myself. I can use some of the managed agent services like OpenAI Assistance v2 or Azure OpenAI Assistance, right? So I can use the tech that a lot of you are already using, put that into a step, have an agent do some work for me or figure out what needs to happen based on its plugins, right? Or the other cool thing, or I can use all these together in one step if I want. I can also do full human in the loop. So maybe I get to a step where agents have been doing work, I've called code, I've called APIs, and now I say, okay, before we move on to the last part of the process, I need an accountant to jump in and just approve this new accounts, right? Or approve the credit scores or approve the discount we're going to give. So I can go and actually have a human jump in here and push out an event and say, hey, can someone go review this? Like, here's all the information we're going to send back out to you. Maybe it's in an redacted card or however you want to do it. go look at this, approve, decline, say no, redo the process or restart the process. So we can either like flow one path or another, or we can even go back up and say, no, this is not what I need. You're missing this part. We can send even that information back to the top of the process or to a particular step and then start that flow again. So you have a lot of good options here with the flexibility of a step. So like I mentioned, everything is event driven. What does this actually look like? So I have step one. So I can say, look, when an event happens in step one, I want to go send the output to some other step. Or I can even say, hey, based on my kernel function within step one, maybe I have many, but when this one finishes, again, send the output of this kernel function to the input of another step. So that's kind of what I'm doing here. So I can just say, look, when this event happens, this should go to one step or many steps. And the nice thing is, even if I have an array coming out, I can even do like, hey, create map from step type. And I can say, when I get a bunch of food orders that come in, right? Let's say I order like a soda and a burger and some French fries. I may need to go set up like 3 different processes, run those in parallel. And then when those are done, I can bag up my order, right? For step 4, QC it, hand it to the customer. So I can do some of these different patterns. Things like fan in, so that's what we kind of saw is I have lots of inputs. I need to go to one output, right? I can fan out, hey, I got this order. I want to go fan out to all these different sub processes that happen or sub steps. I can cycle through, so I can wait for things to happen. And then when they're done, move on. And I can even do things like map reduce. So we give you some good options here based on your process. And we'd love to hear more. So as you dive into this, as you start to create your own processes with the process framework, we want to have that feedback from you to know what else are we missing. So let's look at, if you're still like, what is a process? How can this work? We'll show one today, but we have a couple that we've been thinking about. So let's really dive into account opening, because this is one that we think is really helpful for a lot of businesses. So, all right, I need to open up a new account, right? And I want to make sure I can show the status back to the customer within, let's say, a 5-minute SLA. So a customer wants to build a relationship with us. Maybe they go to a website, they complete a form, they go back and forth, they kind of get the whole form filled in. Right. So that's kind of step one. Then what happens is it goes, okay, the form's totally filled in, the customer hits submit. It goes maybe to our accounting department. The accounting department can determine, what is that credit rating? I want to pull some credit. I want to do some different things to see, can this customer be a customer of ours? Once that happens, it's either approved or rejected, right? If it's rejected, maybe we'll send it out in the mail, or maybe we'll send it out in an email back to the customer and let them know, oh, sorry, for whatever reason, you can't be a customer of ours. Or if it's approved, we can go and do things like fraud detection. So maybe we want to call out to a bunch of different systems, see if there's any fraud based on that business or that account that's happening. Again, if it's rejected, we can go back to that mail service. If it's not, I can go trigger the next part of my workflow, which is, all right, I need to wait for 3 days. And then after I do that, I need to create my core system, get that account ID, send it off to all my subsystems, right? And now my full new customer is set up in all the different systems that I have. And now we're going to go create that welcome packet and send that off to the customer. And I can determine based on that, again, where do I put AI? Where do I put code? Where do I need a human in the loop to do that particular type of work? So that's an example of a particular process that you could implement. And you'll see some, in this one in particular, I think you'll see a sample coming out in the next couple days to help you get started with this one. All right, so as patterns, what did we just see? We saw a cycle for fraud detection, right? We can keep looping through until that looks fine, or we can even loop through afterwards to see, oh, I waited for 3 days. I can fan out from my one core system. I need to pass that account ID to all my subsystems. And then again, when all my subsystems are all finished, maybe they take updates at different times, I can wait and say, great, now I can create the welcome packet because I know my new customers in all my different systems downstream. I can go send that off. So let's talk a little bit about how do you actually code this, all right? So 5 steps. Before we get into that, though, I want to talk about the layers so you understand how it fits into Semantic Kernel. So this is all around kernel functions. These are things you already use today. right? So a kernel function, if you're not familiar, you can call out to different models, different AI services. You can have agents in here, right, inside of your kernel function. So that's kind of the core of semantic kernel. Now I can take one or many of these kernel functions, and I can put these inside of a step, right? And then I can take those steps and I can set up my patterns. How do I want to organize these steps to work together? And then lastly, I wrap all those in a process, and I can say, great, a process is one or more steps and/or processes inside of a process to go get real work done. All right, so what do I do? So let's look at that website Q&A, right? We just talked about that for a little bit. So that's our process that we want to do. Step one, I do exactly what I always do, right? Create a new project. I do using semantic kernel. This is all in C#. Now I'm going to be able to use this new package that just came out a few minutes ago. So I can use Microsoft Semantic Kernel process.core. That's going to get my setup ready for my process framework. And then what you do is you name a process, very similar to kernel, right? So I just do kernel process. I say it's new. I give it a name. And now I have my process ready to go for me. All right, so we're going to use this. We're going to use our website QA because that's the one on the right. Okay, step 3. I'm going to go create a class, right? And this is going to wrap my kernel functions. So my class for this one is called, receive ask. This is, remember, from my website. I'm going to go receive the ask. This is step 1. So what I need to do is I'm going to set this up as a new type. So my kernel step base, that's going to tell us, oh, this is a process step. Awesome. Again, I'll put in all my kernel functions here. And then I'll also set up what's going to happen, what kind of output am I going to have. So I'm just going to create a new class. It can be very light here, again, using your kernel functions. All right, so I'm going to do that. And then step 4, I'm going to go var up my steps. So I'm going to say, okay, I'm going to create my new step. My step is receive ask step. And I'm going to set that equal to my process. Remember, that's what we set up earlier. Add step from type. I'm going to put in, what class is this going to come from? And then one last thing I need to do on the first one, we need to know which step starts our whole process off. So you're going to set is entry true. That's going to tell us, oh, the process is starting. I know where to start, and now I can flow down from there. You can also see here that REI and safety, I've set this up once. I'm going to reuse it across my process. So I don't have to do REI step 1 and 2. I can if I want to, depending on what my business logic needs to be, but I don't have to. And same thing for my format result step, right? I can set that up once and just keep reusing that across my different processes. All right, and then the last step is how do I do my patterns, right? So I'm going to say, okay, for my receive ask step, again, on events, I can send this off, or on this function being completed, I'm going to take the output of that and send it over to an input of something else. So again, it's a lot of the concepts that you're probably already familiar with that you're doing in other places. We wanted to reuse that and make it really powerful with AI. The other cool thing you can do is, again, if we go back to the first example we looked at, so I can say, I have my website Q&A, and I'm going to go, receive ask to my REI step and then keep flowing down. But the other thing I could do is within my process, I might need to say, you know what, if I get something back from prompt shields that's unsafe, I can either stop the process and exit completely, or the other thing I can do is, maybe I want to take that information and I want to send it off to some other service. So that way maybe IT can look at it, or my safety folks can take a look and see what happened here. So I can do things like that. So on the process, I can do on events or on failure, or I have a lot of different options here. But I can go send that off and send this unsafe output out to some other system if I want to, which is pretty great, right? All right. Again, you can use Orleans or Dapper. So what this looks like is you'll see new packages. Orleans will be the start, and then Dapper will come later. So you'll just do microsoft.semantikkernel.process.orleans. That'll give you the wrapper that you need to be able to use this in Orleans. Dapper is going to come when we ship Python. So right now, the process framework is .NET to start. That's today. In the next, probably a few weeks, we'll continue to make progress on the Python version of this, get that out there, and we'll try to put Dapper out at the same time. All right. And then just real fast, a couple updates just on best practices. So as a team, as we've been thinking about this, as we've been using this for some of our internal apps already, we've seen a few best practices that we think would be helpful for this group. So one is kernel functions. Let's put those in its own folder. That way, if I have large teams of engineers that are working on my process, which I might, I can have a team working on my kernel functions. I can have a team working on those step definitions, right, those classes. And then I can have a team working on the orchestration and the registration for my process. So this is a nice way to kind of break these up into 3 different components. And then when you want to do testing, when you want to do updates, you can update one little piece. I mean, sure, you can put this in one huge file, right? But that's going to be a little bit harder to have many, many people work on this and test it independently. So that's some of the things you can think about as you get started in the next couple of days. And then the other big question is, okay, like what's next? What does this mean? Where is this? So, and where does this fit inside of Semantic Kernel? So again, we have our core kernel. This is what you've been using for a while, right? This is the 1.0 service that's out there for Python, .NET, and Java. We have our agent framework. Like I mentioned, this is an experimental today. This allows you to do single and multi-agents. So you can use the agent framework inside of the process framework. You can also just use regular semantic kernel if you want. So if you don't need to use agents, you don't have to. You can just use, again, the kernel functions inside the process framework, and that'll work fine too. All right, so like I mentioned, we have this in experimental today. The package is out today for .NET. Where ADR is out there in case you want to see, how we've been thinking about this. What does this look like? That was posted on Friday. Package out today for .NET. Python's going to follow. As of today, you can see there's a few links in the chat. So we have the blog outs. We're doing our community call right now. We have our doc site that's been updated. Thank you for Sophia for working on that. And then we have some samples out there. We have a really basic sample to get you started today. You'll see more samples coming in the future. And then what we want to do is we want to get feedback from our internal teams that are using this, from you as a community, really around September through October, early November. And based on the feedback that you give us, we think that we can get to 1.0, like a very stable, no breaking changes release for this, at least for .NET and probably Python by early 2025. So that is the process framework. I'm going to pause there. I know we went through a ton of stuff, and this might be new to a lot of folks. So I'll open this up for any questions that you have.
Not really a question, but super excited to see you guys pull this off. I just started down this path yesterday,
Great.
and you just saved me a few months, so thank you.
No problem. Yeah, definitely. Again, Hank, use it. Let us know what we're missing. Again, we've done this with a few apps internally so far and a few business processes. So we think we have, maybe the patterns, at least the ones that work for us, but you may have more. So definitely, let us know on this call. You can certainly use all the normal channels, right? Discord, our issues list, discussions. Right. So let us know what you find and what's missing.
Yeah, for sure. Excited to dive in on it. So thank you.
Great, thank you. Any other questions on the process framework?
So Ivan, you mentioned this is released in .NET as of today, right? Which version of the semantic kernel we should be using?
So you need to use 1.21. I believe that's the one that just came out. Let me double check. Yes, 1.21 will have the new Microsoft.semantikkernel.process.
Okay, all right, thank you.
Yep, no problem. Good. Any other questions? Okay, well, we're excited to see, what you do with it. Definitely over the next couple of weeks, let us know as you start to dive in. And if you have any questions or anything that's unclear, we're happy to, again, you'll see more samples. This is the start. So you'll see more samples coming out, more updated doc sites. We wanted to get you started because we're so excited about this. And a lot of internal teams are too. We think you'll be, hopefully find this useful.
Great.
All right, with
Thanks
that,
so much,
I'll turn it
Evan.
over to you.
Really,
Thanks.
yeah, thanks so much for sharing. And as you're going through and yeah, either later in the call or even as you're going through and this week and next week and testing and implementing this, we'd love to hear from you. So if you do have any case studies you'd be willing to come and share, we'd love to be able to showcase that. And then, as Evan had mentioned, use our normal engagement channels as well to give us feedback. So with that, we have two more announcements from us before we open up to open Q&A. Sergey, do you want to go next with function calling?
Oh, yeah, absolutely. So, in a second, I'll share my desktop. Yeah, I believe you can see it. So I'm happy to announce that we've released new function calling model last week, and we announced it on the previous office hours. But I'll repeat here and show also a few examples how the new function calling model looks like and how you can use it. So if you previously worked with the function calling in Semantic Kernel, so you won't notice too many differences, and that's good because we've tried to design new function calling models so that it's very similar and intuitively clear for you how to use it, and it's similar to the current or existing one. So the benefits of the new function model calling is that it's kind of all the assets, all the classes for the new function calling model lives in abstracts, in abstractions package. That allows it to be used by all the connectors because existing function calling model is supported by the OpenAI and Azure OpenAI and maybe a few other connectors. But again, so saying supported, I mean just it's not shared between all those AI connectors. Instead, each of those connectors I mentioned has its own copy of function calling model, which make it not reusable, and each copy can be used only with a particular connector, while the new function calling model can be reused by all the connectors, which allows you to, which enables scenarios like you've configured your function calling functionality, then you try OpenAI model, and for some reason you didn't like it, or maybe it's too expensive, and you find a cheaper model or with different parameters that more convenient for your scenario, and you can easily switch the OpenAI function, OpenAI connector by the Mistral connector or Gemini connector or any of the model from the Hugging Face that can call the functions. And again, so it's one line, and it's one line at the point where you're bootstrapping your app. So instead of writing something like service collection dot at OpenAI connector, you're writing service collection dot at Hugging Face, and that's what it. So all the functionality related to the function calling will stay the same, and you don't need different else and if else blocks in your code anymore. So that's one benefit. The other benefit of it is that the new function calling model is the model we are going to support from now on. So the old model is not going to be extended after that, and the new function calling model is designed in a way that it's extensible, which means that if tomorrow there will be a model that only supports certain parameters, right? The new function calling model can easily support this. Or if tomorrow there will be a parameter, for example, at the moment there is parameter which we are going to introduce soon is parallel function calling, that basically guiding AI models to call functions in parallel if it's possible. So that parameter again can be added to the options, and it will be applicable to all the models. So yes, the new function calling model is designed with extensibility in mind. So having said that, I'm going to guide you through a few samples demonstrating how you can set up a function calling model, how you can tune it. Yeah. Before leading you through the scenario, so I would like to describe a few functions that are going to be used by those scenarios. So those functions are going to be imported inside this method. And those functions are very simple. One function is responsible for returning the current daytime. And the other one is, again, so it's responsible for retrieving the weather forecast for a particular city, which is specified by city name at this certain current time. And the way how those functions are going to be called, and at least that's what we expect from LLM to do. So LLM should, as orchestrator, it should be smart enough to understand that, like, before getting a weather forecast that requires city name and current daytime, so it needs to call get current UTC daytime function in order to obtain the argument for the current daytime parameter. So the sequence of execution should be get current time, UTC daytime should be called first. The result of this function should be returned to LLM. LLM should get those results and call the second function with that daytime. So yeah, that's a prerequisite for all the samples. And I'm going through the bunch of examples that you can, by the way, find in our samples directory in Semantic Kernel repo. So first scenario is demonstrating very simple example where you are enabling auto function calling, and you are asking model to give a color of the sky in the Boston, and you are putting the function calling settings as a settings for that for the prompt invocation. And with these 3 lines where you are creating, well, there are actually a little bit more lines, but like they're hidden inside create a kernel. But again, so it's not hugely more. So it's like you need to create a kernel, import those 2 functions, create settings, and invoke the prompt. So all those lines behind the scenes, so multiple function call happening. And first, LLM is calling the get current time function, updating the result, and then it calls get current weather and specifying the daytime as an argument for the current daytime parameter. And it's also smart enough to extract the city name as a Boston and providing the Boston as the first argument for the second function. Similarly, you can, instead of advertising, what happens behind the scene, by the way, also is apart from the function calling itself, before LLM can call the function, LLM should be aware of the function, and we call this process function advertising. So what function advertising does is it get all the functions registered on the kernel and tell LLMs that, hey, LLM, we have the list of the functions. And that list of the functions is basically all the functions registered on the kernel, plus the functions metadata, function name, function description, list of the parameter, type of each parameter, description of each parameter if it's specified, and also metadata for returning type. In this way, LLM is aware of the functions it can call. Moreover, it's also aware of the signatures of the functions. And when LLM is about to call a function, LLM can craft a JSON in order just to supply the arguments for those functions. And LLM is smart enough to analyze the metadata of each parameter, and based on that metadata, it is capable of creating a JSON, which Semantic Kernel later deserialize into the .NET types. So for scenarios, for example, when for some reason you don't want to advertise all the functions registered on the kernel, new function calling model allow you to specify a subset of the functions you want to be advertised. For example, in this sample in line 71, we are like getting get weather function, and we are only advertising that particular function. And as you can see, because we're advertising only one function and we don't advertise get current daytime function, we had to specify daytime in the prompt. So, and the reason for this is because model doesn't have the second function. It's in its disposal, but it needs daytime in order to call second function for getting weather. So what next? Yes. Oh yeah. So another interesting thing. So we've introduced 3 function choice behavior. So we have auto, required, and none. Auto allows the model to decide whether to call the function or not to call. And if model decides to call a function, well, it needs to decide which one or more than one, right? But again, so auto doesn't like force the model to call a function. It's just like basically saying, hey, just like if you need a functions, here are the list of functions. But again, feel free not to call if you don't need it for your prompt. The other function choice behavior is required. That's different from auto in the way that the required is basically forcing model to call a function. So model is obliged to call the function. And the third function choice behavior is none, which basically telling the model don't call the function at all and try to resolve the prompt in the way you want. And what we observed is like that's function choice behavior is very good for dry run scenarios when, for example, for certain reasons you don't want to call the functions immediately, but for safety purposes you may decide to look at the execution plan, or you may look at the list of the functions that model would like to call and which parameters model going to use for those functions. And you can easily achieve it with this non-function choice behavior. For example, in this prompt, I asked model to tell me which function it would call. And the model responded me that like, first I'll call the get current UTC daytime function. And then I'll call get weather for city function. And specify Boston as first parameter and daytime as a second one. I believe it's somewhere there. Another thing, another cool thing that new function calling model introduced is now it's possible to specify function choice behavior inside the prompt template configurations. It's not only from the code, but you can do it also from the JSONs or from YAML. For example, this line showing the piece of the function choice behavior, JSON one, YAML one, where you need to specify execution settings. And then you're saying, hey, these are execution settings for default service, and here the function choice behavior. And well, model, if you need to call a function, please use the auto function choice behavior. And again, so it's the same prompt, and you will get the same result. Similarly, you can reduce number of functions that are going to be advertised to LLM by specifying the list of the functions you want to be advertised to LLM. So in this case, we are only advertising get weather for city, and only that particular function which is specified in this list is going to be advertised to LLM. What else? The next example, next sample is showing the how you can do the same with auto function choice behavior, but instead of using the everything that you can do for function calling for non-streaming scenarios is supported for streaming scenarios as well. So this sample is showing that as well. So again, we're creating settings and we're obtaining an instance of chat completion service, but instead of calling the get chat message content async, we are calling get streaming chat message content and passing the same settings. From the user point of view, the function calling model initialization is the same. So we don't have different way of initializing function calling for different type of APIs in Semantic Kernel. On top of the auto function invocation, let me introduce two mods. Well, most of you most likely is aware of two mods, but like for some of you who hear the first time about function calling is, so we have two modes like auto function invocation and manual function invocation. All the samples I showed you before are about the auto function invocations, which mean that you need to import functions and you need to send a prompt. All the rest will be done for you out of the box by Semantic Kernel. And saying all the rest, I mean, so registering the function on Semantic Kernel, advertising the function for LLM, recognizing that AI model is AI model requested function call, then parse that function call, then deserialize the JSON into target.net types, call the function, serialize the results, send the serialize back to LLM, wait until response from LLM and repeat the same many times until LLM stop calling the functions and return your result. Everything that I mentioned happens for you automatically end-to-end out of the box with auto function invocation. But of course, there are scenarios when that's maybe not what you want, or you might want to tweak certain aspects of function calling yourself. And for these purposes, we have the manual function invocation mode. And in order to activate it, what you need to do is basically provide this flag, auto invoke false, with any of the function chase behavior with auto required. This auto and required. The flag is not applicable to none because none is kind of like by default is not presume function calling AI model to call a function. As soon as you activate this flag, as soon as you set it to false, so all the function invocation can be handled by you. So what you need to do is basically provide the settings as you had to do it before to the get chat message content async method. Then you need to wait for response. Then in this line, you need to basically iterate over the function call content items in the chat content message response. So we have this extension method or help from utility method for you that does for you. That method basically extracting a list of the function call content classes. And the function call content classes is another semantic kernel abstraction over the AI model function call. And that function call content contains function ID, function name, plugin name, and arguments of functions. So yeah. After you've extracted the list of the function calls from the chat history, you need, by the way, to preserve the response from LLM and stick it to the chat history. So chat history is aware of the context. Chat history, you need to know that, well, first of all, AI is kind of like a stateless, and the way how AI can preserve the state in order just to follow the conversation flow is basically its responsibility of the client of AI model. And in order to preserve the state, we need to put the AI model request to call a function into the chat history. So that's the line that. And after that, you can iterate over all the function calls in this very simple loop. And what you need to do, you basically need to call invoke async function, which is instance method of the function call class, and get a result, convert result to a chat message and put it back to the chat history. And of course, like you need to handle exceptions if you, well, because when you're calling functions, so what may happen, an exception may be thrown. And yeah, you need to handle it and to handle it in the way you want. For example, in this example, the way it handled is basically we are getting this exception and putting it back into chat history to provide the exception details back to LLM model. So LLM may try to heal because LLM may figure out from the exception method that like, well, this function was called with the wrong argument. And on the next try, LLM will request a function call with a slightly different argument that may lead to successful invocation of that function.
Perfect. Thanks, Dara. I just want to pause for a second and see if there are any questions that have been coming up as you've been going through. I haven't seen any in chat, but I just wanted to pause for a minute and see if anyone wanted to come off of mute. I see we have a hand up, Pradeep.
Hi, I had a question. So thanks for the detailed walkthrough. So whatever you've just shown, so this is with using native plugins, right? So I'm assuming the same would work for OpenAPI plugins also.
Yeah, there is no difference between either native or OpenAPI. So as soon as you imported plugin to the kernel, so there is no difference between those two.
Okay, thank you.
LLM can call any of those.
Okay. And sort of the follow-up question I had was, and we were actually using planners quite extensively, and as I understand, these are going to be deprecated in favor of something like what
function
similar
calling
to the code interpreter feature, right? When is that any AT on when that would actually be incorporated?
I'm aware of the planners deprecation plans. Yes, we are going to deprecate them in favor of the function calling because it appears that like AI are much better in orchestration than our planners. I believe just Evan or Dmitry can give you more context about that.
That's right. Yeah. So you can continue to use the planners we have today, right? Because they're out there. They're really just prompts. But as Sergey was saying, just come off the video. As Sergey was saying, you'll get way better responses using function calling with a lot of the new large language models. Again, they've been doing a lot of work to take what we've been doing in the past, since there was none when we started Semantic Kernel 18, 19 months ago. But now there is, and they're, again, you get really good results. You get results that are high quality and reliable for most of the time, unless, let's say, the models, getting like 404s or something like that, or you're getting throttled or something like that, which is why we have the piece for error handling. But yeah, that's definitely the way to go. If you're going to do anything like at full scale, the function calling is a better bet. And I'll paste in a link. We actually do have a blog post about the path forward for our planners.
Okay, and in that, interestingly, you also mentioned you'd be introducing like a code interpreter like feature that can actually be run locally. So
yeah, so we have that today. So it's not local, it's within Azure Container Services. So it's the code interpreter that you'd see like from OpenAI, actually, where it can go write Python code, or you can run Python code. So we'll paste in a link there. We have a few samples of getting that going that you can use today if you want to go down that route.
Okay. Thank you.
No problem.
Perfect. Thanks for the question. I see we have another hand up. Brett, if you want to come off of mute, we'd love to hear from you.
Yeah, sure. Thanks. I just had a question about if there's any plans to add the OpenAPI or OpenAI API version as something we could configure for chat completion models, because with the release of the new 2.0 beta of the OpenAI client, that changed the response model for content filters. So I was still on 1.16 Semantic Kernel, and that actually broke our content filter logic. So I'm curious if that's something we can configure, because it looks like it is something that's set up in internal classes within the Semantic Kernel, but not something we can actually outwardly configure when we're creating those chat completion model instances.
You should try to go, and the team can correct me if I'm wrong here, you should try to go to OneNet 18 Plus. In fact, I'll put a link here, because we do support the new version of the SDKs. And we have a guide here for you. Go.
Yep. So yeah, I'd already gone through and done that after I saw that this was an issue. But I guess, yeah, since this was like a 1.16 full release, not a preview, that's something where if I hadn't done that and we had triggered like an automated build for prod, for example, that would have broken our production instance. So I guess, yeah, the question is then, yeah, are you guys either going to add upward bounds on that OpenAI version so this doesn't happen in the future, or B, is there a way we can actually set that API version? Because yeah, one way or another, like I said, this could have been very problematic for us.
Yep, that's definitely a good point. We did a few things, and I think apparently we could have done more, because if you didn't see it, that's on us. We did do release candidates for about a month out to let everyone know, hey, there's a release candidate out. This is something you have to make an update to if you have these scenarios or you want to use the new clients. So that's probably on us to do like broader comms to make sure everybody was aware that this was coming.
Yeah, and I noticed actually as well that there was an issue open with this particular question, right? So I'll take a look, and if you can't configure the API version, like we'll look at introducing a fix for that.
Okay, because yeah, when I looked in your source code, you do have like an OpenAI client options internal class that just has it set as the latest version in its default parameter, and that parameter isn't something that's outwardly configurable. So yeah, if that was something we could set, we could avoid all this. Or yeah, otherwise, if that connector just has its own bound on 1.0 stop, then that would have, either of those would have worked for us. But yeah, either way in the future, that'd be much appreciated. Thanks.
Yeah, no problem. Yeah, you can actually create an instance of our service and pass in the OpenAI client directly, so you can construct it yourself. So that might be the way around it. But yeah, let me confirm this, and I'll get back to you.
Awesome. Thanks. Yeah, I hadn't seen that, so I'll take a look into that as well. Thank you very much.
Okay.
Thanks, Brett. Really appreciate the feedback. Any other questions for Sergey and function calling? If not, there's one more item we'll cover and then have some additional time for Q&A. But I've been keeping track of the chat as well. Haven't seen too many. Dimitri, I'm going to share screen to go over the one last item. Does that work?
I can share my screen and jump
perfect.
directly
Okay,
to the
thank
code
you.
since we have limited time. Yeah. Let me share my screen real quick. And please confirm if you can see it.
Yes, I can. Can others see it as well? Perfect.
Yes.
So, sounds good. And I'm going to share links to the sample, which I'm going to show today, and also the general information about the structure output. So basically, last month, OpenAI released the feature called structure outputs, which basically allows you to specify a JSON schema as a response format to your prompts. So last week we released this feature. We released the support of this feature in Semantic Kernel as well. And it's worth to mention that this feature is supported, like not all of the OpenAI models support this feature. So there's a list of supported models, which I shared in the chat as well. So you should, in case you see that this feature does not work for you, just double check if you are using the correct model. So this feature basically, so there's like a response format parameter in OpenAI API. It allows you to specify like what type of format you want as a response, and it can be text, it can be JSON format, or it can be JSON schema. So the differences between JSON format and JSON schema is that when you specify that you want a response as JSON format, the model will generate some response for you. It's going to be in JSON, but you don't have a control over the schema of that response. So the model sometimes may produce like random JSON, and you don't have, especially if you're working with C#, for example, you don't have a way how to deserialize it to a strong type, because the schema as a response may be different. And in order to control it, you have to specify additional system prompt, for example, or put your instructions in the user prompt that you want some specific schema as a response. But with this structure output feature, you can specify JSON schema as part of API. And in Semantic Kernel, we have a couple of ways how to do that. So first way how to do it is basically to define your own chat response format object. So basically, I'm initializing kernel here. I'm using the model which supports structure output. And then I'm initializing the chat response format, which contains my JSON schema, and I pass it as a string here. But for example, you can store this JSON schema in a files, for example, if that's more comfortable for you. But you have a control over it, so you can specify, what properties you want as a response, and what types of the properties the model should return. And then as soon as you have this chat response format object constructed, you pass it to OpenAI prompt execution settings to response format parameter. And then I have a simple prompt like, what are the top 10 movies of all time? And as a response, I want this array of objects, and my object should contain the information like title, director, release year, and so on. So as a result, I will always get a string, but take into account that I specified the response format and this JSON schema, I know that my JSON as a response will be in specific format. So I can be sure that I can, after I get my result, I can simply deserialize it. For example, I have this structure here, which is movie, and then it has all of these required properties, right? So I can be sure that my response will be deserializable into this format because I specified it basically in my request, right? So then I can basically deserialize it, and then I can output the results by accessing all of the properties without any issues. But with this approach, like there's one small disadvantage, is basically that in case you want to specify your schema by yourself, you have to do it here. And then if you want to use strong type in your code in order to work with it later, you have to specify your properties in your class or structure as well. So basically, there are two places where you need to specify your properties, which is not the best approach in terms of maintenance, although it's kind of flexible. But in Semantic Kernel, we have another option, which basically allows you to specify your type of a response directly. So here I have, again, I'm using the same structure here, which is like the movie, and then I have like all of the properties required, which I want to get in my response. And then I basically, I take this type and I passing it directly to response format property. So response format, it's kind of like a flexible property which can accept either this chat response format schema, or it can accept your types directly. And then I have the same prompt, like what are the top 10 movies of all time. And then again, I can be sure that I will receive this exactly type back because I specify it here in response format, which means that I can simply deserialize it and then work with it as with strong type, basically. And then we have also another example, which shows how to use structure output together with function calling. So here I have a simple plugin which shows me how, which basically has this kernel function which returns some emails. So basically those are email bodies. And then I have a simple prompt here, process the emails. But as you can see, like I don't specify exactly how I want AI model to process these emails. I just basically specify a task, process the emails. But then as a response format, I have this model which basically says that as a response format, I want an email with the property body and property category. So I already have body in my plugin, but I will also want a category, which means that basically I can control the model behavior by using like C# strong types, because I can say, okay, I want a category, but also I want some, additional property here, some, description or something like that, right? Or maybe summarization. So, and then with this simple prompt process the emails, I'm passing this, EMEA model here. And then as a result, again, I can be sure that I will get, this result in a specific format, so I can simply deserialize it. Then, I can output, the body and the category of each email. So, yeah, this is it basically for the structure outputs. And yeah, if in case you have any questions, I will be happy to answer them.
Yeah, thanks, Dimitri. Really appreciate it. I'm just looking in chat to see any questions specifically on this. Does anyone want to come off of mute? If not, feel free to use our GitHub discussions. I know we're a minute or two over, and so just want to thank everyone for your time and for attending and diving into all the content. We'll also have upcoming office hours where we'll talk on some of our other features. So if you are starting to use some of these items and have questions, feel free to join there, or also use GitHub discussions in the interim. With that, I'll go ahead and end today's office hours. Thanks so much, everyone, for joining.
Thank you.